Hello, 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 folks. Thanks for coming on by. Admin of Code Day 16 is 45 seconds away. As usual, got my template file up. TypeScript is ready to roll. We're missing the music. There we go. Let me fix that timer now. 27. There we go. And yeah, as always, got my TypeScript template up, my Quokka ready to go. Let me make sure cause I think last night I forgot to do a good old git push, so repo's updated, it's running, Quokka's ready, input files ready, everything is ready to go. Yay, Xmetrics, I appreciate that. Thanks for coming on by. Hope you've been doing good these past, I don't know, feels like it's been a week at least. Okay, blah 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 things, flow rate, that sounds like a math, vowels, oh lord. Okay, interesting. Here's my sample input. We love a good sample. And I know we love putting the sample where it belongs, right there. Dedent. Clean that up. And let's figure all this out. So vowel rate tunnels. So const parse flow info equals data string. We love this. Turn data to split by all the new lines. Then you're gonna map every new line to say, oh great, what do we want? We don't want to jump. We want to say valve flow tunnels. Ooh, split by colon. I love that. Valve name flow rate has flow rate. Good copilot. Hey, Skyvane. Yeah, I am doing well. Tunnel names, do that, split by comma. Great, now return all the things. Valve name, flow rate, tunnel names. Great, should be all the things. Const flow info equals parse flow info. Log flow info. This is the part where Quokka does its job. Do your job, do your job. So split after lead to val, split on comma. Comma not always gonna be there, although cannot read undefined. Lead to valves. Oh, leads to valves. Interesting typo. Tunnel leads to valve. Oh, I got it. Okay, we can do some regex on that. Hello, regex. Welcome to the party. This S is now conditional. Are we cool? Why are we no cool? We should be cool. IG. Why are we no cool? Let's log the tunnel. What tunnels we got? We have undefined. Great, we've already broken this. What line are we on? Valve has flow rate. Tunnels is split on the semicolon. Oh, it should be left and right. There's only two. Great. Val tunnels. Okay, looking better. Tunnels. Each of these has things. Oh, I can split on valves. Conditionalize the S. There we go. Regex, not always our friend. But okay, we have these in there. It is a little bit of TypeScript there, Nils Vakaselen. Thanks for coming on by. Well, this is Mike's solution for Advent of Code Day 16. Running against the clock, trying to see how fastly we can get this done. Yeah, just throw it all away, obviously. That's the solution, dumpster dev. Okay, let's start on the actual problem. So all tunnels are closed. You start at AA, but SB thing. Flow rate is 0. 1 minute moving to BB. 1 to open. Release pressure during the remaining 28 minutes at a flow rate of 13. Great, so freaking math. Okay, CCDD. Okay, so wow, it's math. Sounds terrifying. So I guess we're gonna say, so I have to go through all of this. You need to release as much personal method ooh, so I have to only open the valves that are releasing the most pressure to the most ones. So 20 versus the 0, gotcha. So then I go from these ones to the ones that are open. Okay, so it's kind of like a pathfinding algorithm. This is Dijkstra's. This is my cost. These are my new edges. It's a graphing algorithm. This is going to be tough. So while while flow info dot length or const close equals flow info. So while there are any close dot length, I guess we could do that, and we're gonna go in here and say const next equals close dot pop. But here's the pathfinding part. I have to figure out which ones I should open. So I open D, then I go to C. Why do I go to C? Why don't I go to A? Oh, flow rate is 0. Why don't I go to E? E is a flow rate of 3. Yeah, why don't I go to E? That has a higher flow rate. Valve is D, releasing 20. So I move to C, move to B. Wait, why did I just do a double move? So I open D, then I move. Oh, moving to cost DCB. Oh, moving cost 1 minute. Ah, what an interesting algorithm. This is where I was like trying to feed it to one of those solvers. Most pressure, valid layout, amazing. So I guess the minute cost. Ah, I got it. So I go to B because B is double what C would have cost to get to C. So B opens 13, and C would have only been 2 times 2 is 4, because it would have cost 2 to get to C. Will cost 1 to get to C, and B is at least double it. Okay, I'm starting to understand this. It is a very meticulous, lots of details, getting all these costs together. So what I need to go is I need to pick one. So pick one with the highest rate to the most, and that will be my heuristic to pick the next one. I can start off with whatever one I want. Okay, so const start flow equals flow info dot reduce, and then most open is, that's not that smart though. I guess we'll do ACC, valve name, flow rate, right? Something like this, and then we'll initialize with, of course, one of the initials. That's fine. Valve. There we go. If it's A, if that's not what we're doing. If valve dot rate flow rate times valve dot tunnel names dot length. Nope, stop it, Copilot. It's greater than ACC flow rate. Yeah, so basically if you're opening more, do the valve, otherwise the ACC, which means start flow should be DD. Copilot, get in there. DD. Okay, we got that one going at least. So I guess we'll just do this like while flow, or while close, yeah, so, and then we'll say let next flow, next valve, there we go. While closed length, we go from next valve to where we need to go. So I guess we say next valve, closed, nope. Splice, so yeah, get rid of next valve, say goodbye there. Now we have all of possibilities, so possibilities are opened valves, const opened equals hello. So once we do this, we're going to say push all of the, I guess we're pushing close, and we're additionally pushing, yeah, so those are the opened ones. Possibles. Well, technically, this doesn't matter what possibles are. So it's not I have to start at one and go to the next. It's that which one will give me the most flow times thing. CCAAEE. Yeah, so it's literally the same heuristic for all of them. Okay, so next valve equals this logic, so close, reduce. Okay, this might work. So get the next one, don't assign it to a let. And yeah, so reduce of empty array. That is sad. I guess we're going to say, hey, if close dot length, and no dot length if it's empty, and return. And open should be in the correct order. So now I just need to validate. Console log opened dot map. Yes, valve name. Thank you. I didn't need. Why are you angry? Why are you angry? What are we pushing? Pushing arrays. That's not what we want. Next valve. There we go. Log. Why you know log? Loop never gets broken? It's gotta get broken, because we run out of things. Oh, we return. We don't break. There we go. So, DBHJE. DBJ. So H is not as great as J. H releases 22 to one valve. J releases 21 to one. Oh, here comes the cost, right? Okay. So cost to get to valves. So we go through close. We do a little mappy map. It's not that. It's alphanumeric distance. So it is difference in first character of valve name. Cost. There we go. That's correct. And just return the cost. I don't think I'll need to remap this. I can use indexes. So cost to get to next valves. Hit me with the return valve name versus. Well, that's not right. That ain't right at all. That's not math. Okay, who's closed? All these, and who is the one I just DD, right? So you got tons of different. Well, that's not it. It's last character. Great. Will you accept a -1? Are you cool like that? You're not cool like that. Great. I can hard code it. VALVE 0 1 2 3 4 5 6. There we go. Now I get my cost to get to next valve. And here's the thing, I also need to pull the index here. So my total cost isn't just this. You multiply it by the cost to get there. Here's the thing, it's a negative. So my cost to get to C is 1, but to B is 2. But B is more valuable because 2 times 2 is 4. So it's an inverted number kind of thing. Math. So if I get the largest, right? No. Okay, what are these to go to, right? Next valve. And let's go ahead and just do a for each on this. This literally doesn't matter. For each valve, congratulations, add a cost. Cost equals, do the math. Thank you, good sire. Yeah, and it's angry because TypeScript, but that's okay. We'll add a cost of 0 because it's initially 0 the hero. Now we can just look at the valves straight on. Yeah, so get to A, 3, 2, 1, which is the reason we go to B. Okay, these names also suck. Drop those. Don't know who picked this name. I picked this name. Valve split. Valve name dot split. The spacey thing. Index 1. Valve. There we go. It should look a lot better. Great. Now it's just the letters. Okay, so going from. Who are we going from? Next valve. So we're going from DD to technically any of them, but from DD to AA is 3, BB is 2, CC is 1. Yeah, math is good. Now we need to figure out, so if I get to that in 1 versus I get to that in 2. So I need to multiply this cost by the highest cost to get here minus the cost of view. So DD to CC, while it is 2, No, I need to divide it by the largest one there. Something. I need to do math. Math, daggone it. Okay. It's not exactly Dijkstra's. Okay, let's look at this logic. There's no point in opening it. You could spend one move to LVB. When no valves are open, you move to DD. However, consider this approach. DD is open. Then I go to BB to open that much. AIJ. Oh wait, there's a wraparound. That's cool. That's not cool. Is it? It really wraps around. Yeah, wait. Yeah, I go from D to B to A. Oh. So it's an absolute difference between the indexes of the valves. So math dot absolute difference of the cost, the difference between the numbers. But if they're on the same ends, okay, well, that blows this algorithm out. Even if I did have it working, which I do not. For part one, it's getting me. Maybe I could go full out Dijkstra's or A star. So I have costs, I have weights. No, I would still need to calculate the cost. So I'd still need to calculate these costs properly. So cost is distance. Yeah, we rephrase this variable. We need to calculate the distance. Cost straight distance. Straight distance is that one. Cost round distance. Not plus 26. It's basically, I can do a while loop. So left distance, right distance. Cost decrement distance equals from next valve dot r code, no, valve name r. No, we're not doing that. Okay, we also need all the names of the valves. Valve names equals, yep, map sort. We also, yeah, I guess we want map sort. Oh, I bet in the real one can't use this indexing. Nope, we've got to use both characters. 11 that. Okay, so decrement distance is valve name. So let while decrement distance. So I can't replace these with numbers. That won't actually help me at all. I'll still need to loop. It is this loop, right? So you go from, I open B, I go to A, I, J, I, A, D. Yeah, so you can go, it's a circular array. So let index equals valve tunnel names, perfect. Let deck distance equals 0, while index is not, so while index not equal to, so this is my current index. So my current index is next valve not equals valve. Cost target index equals, we can do this one. Valve names. Oh, I just goofed that one up. Okay, wait, that works actually. Valve names. Great. So while index not equal target index, index minus if, well, first do the check. If index, we can do this check here, index less than -1, index equals there, otherwise continue doing your job. Okay, now we need to let ink distance, and we're going to do it that way again. If it's greater than length, good, set it to 0, wrap around, and finally we have our maximum distance. which is math max of both of these. Deck, instance, and actual distance. Don't need that. Okay, let's figure out this one now. So, my distance to A is 8, B is 9, C is 10, E is 11, F... That's not true. I am D. It literally takes me 1 to get there. What are my valve name indexes? Oh, we have multiple valve names, don't we? Yep, throw it in the set. New set. Then drop it out of the set. We shouldn't have multiple in a set, actually. Valve names. Let's look who we got. A, B, C, D. Looks perfectly fine to me. So we have the valve. Alright, so the index from the current one to the target one. Let's suppose output target index versus index. Yeah, so my index is 3. So from me to A. Ooh, I want minimum index. All these go around the longest way. Now they go around the shortest way. There you go. Which means distance of J is 5. I is also 5. 3, 2, 1. 1, 2, 3. Oh, it's 5 from both. B, C, D, E, F, G, H, I, and J both have a distance of 5. That doesn't seem right. Okay, let's log it. So we'll log all of it. Val name, deck, and index. There we go. Okay. Oh yeah, these ones got big ones. 110, C and E. And both I and J do have a minimum of 5. Okay, I'm right. Or I was wrong. It was right. Love to see it. Say goodbye. Say goodbye. I know how to delete variables. Okay, so we're calculating our proper index now. Now to figure out our cost. So our cost to go to C is 1 times 2. That's not right. Our cost to go to... Let's actually look at this example I got. So A is 0 times 3. Very useful. Wait, do I open A at all? I open C, D, H, F, G, B. Move to valve A. Wait, which one do I open? Oh, I never open valve A. Yeah, because it's useless. Love to see that. I probably need to keep it for some reason, though. Okay, again, let's look at our algorithm. So to B, we have a distance of 2, a flow of 13, 2 times 13. It's not like that, though. It's 13 divided by 2. There we go. We perform division on all of these. 2 divided by 1. Okay, there we go. Return true cost. And so then valve... True cost equals valve distance. Excuse you, it is flow rate divided by distance. I was like, the math. I have to invert the math. It's called freaking division. True cost 0. I want the one with the least cost. So true cost greater than true cost. I want the least cost. I don't know what that's about. So if ACC true cost, then valve true cost. Oh, I put the wrong one in the wrong spot. Okay, I guess these symbols will go this way. Great, so DAF. What the heck? Okay, let's look at our closed. Now you have a true cost of 0. Oh, that's awkward. True cost of 6.5, true cost of 2. Not the highest. Oh, my brain's loading on that one. I want the highest number. DBJHE. So, move to valve. Okay, I need to look at all these open valves because I can't read this. Highlight all. Yeah, so D, B, J, H, E. Oh, we got it. C. Oh, look at that. Awesome. Okay, now I need math. Great, I love math. Okay, so we have the algorithm, right? Let's see. 20 pressure, 33 pressure. It's just total pressure times minutes it takes, right? I think I read that a while ago. Yeah, so every minute some valve's open, I multiply it by pressure. Great. So let pressure equals 0. Let total flow, I guess total flow is correct. I guess we'll say valve minutes equals valve distance. Yeah, 'cause that's what that is. So minutes, great, we have another one. Minutes, 0. Okay, great. So as we do the closing, which happens right here, what we do is we say, great, pressure is, add that to the flow rate, total, no, that's not right. Next, valve, we make a little while loop. For let m equals 0, m. I think that's about right. Total flow increases by pressure. Well, pressure also increases. Yeah, that doesn't do that. So pressure increases by what you open it by, and then we go by for X minutes. And so I open D, then I move to C, move to B, move to B. So it's either off by 1, it's off by something. I think I can finally return total flow as I get off by a little bit. Yeah, off by 81. Well, I also need to simulate 30 minutes. Let minutes equals 0. I guess I'll need to increment this accordingly. Okay, so how many minutes did we end up spinning? 22. Okay, so while minutes not equal, well, it's less than or equal to less than 30. Go while. Probably did my math wrong. B, C, D. So I don't open any more valves after that, which is cool, I guess. Okay, I can log my pressures while I'm doing this. Where's the thing I want to log? Pressure. There you go. So 20, 33, 54, 76, 79, 81. Okay, you know what? Let's go on up here and we'll log all of our individuals so I can count with my face. Oh, it's a lot of counting. Maybe I opened it too soon. So we have two 33s. Well, opening actually takes 1, right? So maybe we don't increment first. There we go. So we have 3 20s actually. How many 33s? 4 33s. Okay, we're doing 1 less than we should be. Less than or equal to. Yeah, 3. Did we math it right? It's too much math. Let's see what we got here. 3 20s, 4 33s, 3 54s. 1, 2, 3, 4, 5, 6, 7, 8. 8 54s. So I go from JJ to HH. JJ goes to HH. One, two, three. Okay, ABC J. J I A D E. Hold up. Hold up. That doesn't make sense. So valve names. If I'm at J, Why don't I just go 2 to H? Move to I. Then I go to A. Are these not ordered alphabetically? Did I goof on the ordering? A, B, C, D, E, F, G, H, I, J. That's alphabetical, yeah. Oh, wait, is my pathfinding not going letter by letter? Tunnels lead to valves. Oh, I completely forgot about that. So I have to actually calculate my distance to those. Okay, it's not the worst, it's not the worst. It's all here, I just need to get there. Shortest path. Ah, great. Okay, maybe I can ask Copilot to do something for me. So we're not using valve names. Congratulations. These suck. Okay, so let's see if we can ask this thing. Shortest distance from next valve to valve. Might be too much to ask. Don't use valve names. Yeah, these literally mean nothing. Flow map. Traversing through valve. What do I call it? Tunnel names. It's literally Dijkstra's, isn't it? Dijkstra. I think it's tough. Copilot's take me down the wrong road. I can look at an old solution, maybe. I'm not paying for Clocker right now. Appreciate you, but not now. Oof. Okay, this is the one I tried before. Thing is, it's based on edges. I mean, I have all the information. I just need to figure out the edges. If I build a graph, that will allow maybe... Okay, so this is the BFS. Just need to generate the data out. Hey, Ryan, how's it going? We are here building yet another pathfinding algorithm. Graph is this. Come on, Copilot, for cost valve of valve info. Okay, I can say record of string. Yeah, how you doing, Ryan? Set string. New set. Congratulations. Valve name dot add tunnel name. We love a good graph. Everyone loves a good graph. Okay, so now calculate shortest from next valve to valve via graph object. Please be cool, Copilot. Where's this coming from? You get this bad code populating your bad brain. We're gonna get rid of it. Say goodbye. So we'll put 1 here until I get this. There we go. Here's my visited. Maybe we don't. Okay, I didn't even tell it to use Dijkstra. It's just figuring it out now. This ain't very expensive either, because there's a lot in here. Great, we have lovely comments. Current instance Q shift. Okay, it's dumb. It's not smart. As array string number. Be cool. Type or undefined. It's not undefined. Be cool. Okay, great. Now what we have here is if visited has current, if current, there we go. Where's the next valve? Ah, Q contains all my things, right? So if I log my Q, hit a return, And okay, we're doing too many things, but my first Q, E, D, B. Like, can I only go through A, B? I should be able to access the entire thing. I'm not seeing. Doesn't make sense. Doesn't make sense at all. Valve. Let's look at the valve we're going from. So we're going from. Let's get double console log on this. Console log, hello. And hello. Drop that. There we go. Now we have it paired with our possibilities. So to A, I can go through E, D, or B. E is 1, D is 2, B is 2. These are bidirectional, aren't they? I bet they're bidirectional. So A goes to D, and then D goes to... Oh no, thankfully they are doubly linked. E goes to F, F... Okay, phew, I didn't have to do that. So from D, I can go to A with a price of 1 through E. Wait, I am price... Okay, I'm not really doing the dice shows right here, because I'm using to find one when I should be finding how I get to all of them. But it's okay, we're here now. So to get to A, when am I using valve in this equation? If current is valve, then valve distance, found. But distances equals create lovely array, push it. Well, I don't trust this. Since it's push, because it's supposed to be, I think this should go shortest, but distances. There you go, so you got 1, 2, 1, 1, 2, 3. Great, so everyone and their mothers here. I guess we can just say, put a break here. Let's get rid of the break. 1, 3, 3, 2, 2. Okay, it looks like the first is the best. I did not need to go that far. It was already doing what I needed for me already. Great, so now if this is correct, big number, DJBH, DJ. Why did you go to J first, huh? Tell me that. So you, number D, decided I'm not gonna go to A or B, C, D, E, F, G, H, I, J, because you have a true cost of 7, so I want the one with the least true cost, but the one that actually returns the most value. So least, but not a 0. Great, so I guess I can filter all the closed out. Where's this thing? Close. There we go. Filter V dot flow rate equals 0. We don't care about you. Now here's the splice. I'll watch out for this. CI equals here. CI. There we go. Just for safety. Great. Undefined. Drop that return. DAFG. Well, did you just hit all the zeros? AFG. Well, I swapped that around it and keep the ones that aren't zeros. Duh. DJ. Okay, why is J in the... Oh, I have to flip the Boolean now. DCEB. How did I have it going correctly first? I'll go back to my correct implementation, and I use this only for something else. To calculate minutes passed, right? Okay, I really gotta go back on this. This might not be accurate for it all, though, but we might get past the first one. Come on, get back, get back. Come on, get back, get back. Okay, this is when my suspicion kicked in. So, this ain't actually correct, unfortunately. Big sad, we are sad. So I calculate minutes by the actual distance we are. This logic. Okay, so let's regenerate a bit of this, bring back the graph. So distance is great, but minutes is what we calculate our own thing with. Cool, 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 cool. Bring back the graph, drop this console. Oh, didn't mean to drag that. There's our lovely Dijkstra, big fan. And instead of setting distance, I'll be setting minutes. I guess I didn't need that one either. Yeah, we'll drop all these references to distance as minutes. Just technically a distance, but we're here now. And great. Did that math out? 2542. Okay, what are we outputting? 320s, 433s. 1, 2, 3, 4, 5, 6, 7, 8. 854s. 1, 2, 3, 4, 5, 6, 7, 854s. 1, 2, math. 1, 2, 3, 4, 476s. 379s. It seems this might be working. And then 1, 2, 3, 4, 5, 6. Oh, Lord. Okay, so it's happening. Minutes is 28. Total flow is 238. So obviously I've done my math wrong. Okay, let's see what this log is. So all the valves are closed. Start at valve A. However, you can spend 1 minute moving to valve V. Okay. Remaining 28 minutes at a flow rate of 13. So it's really whatever this math is times... What the... I spent 2 minutes. Means I have 28 more minutes of go. Math. Have I done this wrong? 20 plus 20 plus 20. That should be mathematically equivalent to 20 times 19, right? Node. 20 times 29, rather. Yeah, it's 580. So all my total flow increments are here. If I just don't do it here, I can say total, or for the one I'm closing actually. So let's just say goodbye here. Say goodbye. Pressure does go up, but not in the way I care about it. So total flow plus equal pressure times minutes. That's 30 minus this minutes. That math out? Nope, that didn't math out at all. Total flow is not going up. Well, it's technically minutes spent. So it's not... Okay, let's log this. Oh, it's minutes minus this, right? Yeah, so it's minutes minus however many minutes this cost. This next valve dot minutes. No, bad math. Baddest of math. I also want to see how many minutes I have left. So minutes times next valve. Oh Lord, Copilot, you lost your mind. That's not it. So it's how many minutes this one is gonna. Minutes is how long it takes for me to travel. Which is how much it takes for this thing to work. The whole point of that was to calculate that. So 30 negative minutes. Okay, so this one's open for 30 and then minutes increases by however many we needed to go. So you're spending 26 minutes at what pressure? Oh, so we're not adding to pressure. Well, it's because we're using next valve dot flow rate. Great, so 30 for 20, 28 for 13. Okay, so math is off. I need to increment my thing. 30 times how many being incremented right there though? 30, 30. How many minutes are on this one? Okay, so this is being done too soon. I need to do it after I calculate the something down there. The one I choose to go to. Down there. There we go. Well, it takes 1 minute for me to open this thing. If a minute 3 forward, so it's 0, 0, 20. Okay, I think I can get it. I just have to get the math right. Or the order of operations, where all this happens. I think my manual simulation, as brute forcey as it is, should work. Okay, so it's the pressure is 0 for minute 0, then for minute 1. Okay, my minute counter is off. Let's set minutes less than or equal to 30. Make math easy for me. Because minute is minute 1, right? There we go. So minute 1 is 0. Minute 2 is open. It's not less than or equal to. Okay, it costs at least 1 minute to do everything. Nope. I have to add how many minutes all this takes. There's my minute calculation. Here it is. It takes at least 1 minute to do things. Where's my output? That means it's open for one more. So 20, 20, 20. Nope. Move to D. Open D. Okay, so I guess just what, 1 minute passes, and that is implied in my calculation. Okay, so it's not logged unfortunately, but here we'll fix that in my brain. Boom, there it's logged. So we have 0, 0, and we have 320s, 433s, 8, 4, 3, 2, 3, and then all of these. 2, 3, 4, 5, 6 81s. Come on, get that scroll on. 1, 2, 3, 4, 5, 6. Ooh, excuse you. Why do you keep doing things? You're done. You're done. Next valve. Valve names. Yes. Oh, come on, console log you. Yeah, so D, B, J, H, E, C. We don't want. Why are you going? Why are you going to these closed ones? They're closed. Get rid of them. Don't care about them. I'm not doing the filter? Or that? I guess I got lost that filter. Filter, valve, valve, not this. Valve dot flow, right? Yep. Ignore the zeros. There we go. We'll make it all the way to C. How many 86s we get? None of them, because we have to fill them all in. So 1165, 18 minutes of total flow increasing by pressure. Now what is pressure? 81, right. Also log this. 1, 2, 3, 4, 5, 6, 7. So we get to 24 with 79. And we also need to log, I guess, up here, paired with pressure. We'll go ahead and increment minutes inside this thing. It makes no functional difference, but it does make math go easier. Okay, so minute 1. There we go. We make it 23 whole. We open valve CC last. Yeah, and then after that, it goes to 84, right? So then move this log around. Well, the whole log, why don't we here? 1, 2, 3, 4, 5, 6. That's math. Oh, we're close again. 1, 2, 3, 4, 5, 6, 7. Drop it by 1. That's math. Phew. Okay, now what the heck is part 2 gonna ask of us? No, 10445. That's never what we want to see. Uh-oh. 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 So my choosing for the next is disconnected from my traveling to the next. Which might be my issue. I'm cheating by using these indexes which have absolutely no meaning, and it just happens to work, so... Oh, wrong symbol. Now I have to try and remember why I didn't even like this in the first place. So this, what I left off on, I think all my code's over here. Great, so how many minutes it will take, we have calculated that. Why couldn't I use, because it gave me the wrong order for some reason. So let's look at next valve. Here's up if the return or close rather. Then we'll output the next valve. See why you went that way. Okay, so yeah, the next valve we chose from DD was HH. You have a distance of 2, a minutes of 4. Your distance is minutes. What is wrong with you? Oh, wait, literally what is wrong with you? Distance, ooh, different variable, minutes. That's awkward. Okay, you don't have a distance, you just have minutes. True cost is calculated based off of distance. Quick math, drop the distance. Ah, now you're going to JJ. Proud of you. DJBH. D. No, I'm not proud of you. I'm unproud of you. I'm disappointed in you. So you went to J because the distance, the minutes is 3. Okay, true cost of 7. Compared to all the other ones, where B has a true cost of 6.5. Should I seal these? Because you're the only one that's being competitive. So from D to J, or D to B. So D can go 2 to B, or D can go, how do you get to J? 2 to J. No, wait. J goes to I. D goes to, how do you physically get there? D, A, I. And each one's a minute, so that's multiplication, which is division. I have it right there. Okay, so I guess I'm logging it's flow rate divided by how many minutes it takes me to get there. Is this correct? J takes me 3 minutes because it takes me 1 minute to go to A, 1 minute to go to I, 1 minute to go to J. Yeah, that's 3. I did math. B, it takes me 2 minutes because I go to A and I go to B. Right. You have a flow rate of 13 versus your JJ's flow rate of 21. So I guess I will need to seal. She feels like cheating because mathematically, yeah, so I will seal it and go with the least minutes. And it doesn't feel right, but okay. Math seal. Then I'll have to choose to go with the one. Well, no, I can't choose this. This is not a safe. This is not safe. I have to. Maybe it works. Where's all my things at? Oh, it's missing. Maybe you just want to work. Would that be cool if you worked? DBay What's the order again? D, B, J, H, C, and E. Okay, so it's probably my calculation. If true costs are the same, so if ACC true cost, B, or value true cost. If minutes, there you go. Choose one with least minutes. Otherwise, live your life, I guess. I do see that being ran. Where's my ordering? Oh, progress. Bigger number. Okay, okay. Big number. Dang. Oh, this ain't good, because I feel like this is working. Oh, we should turn off this one now. Okay, D, B, G, H, E, C. Maybe I need to consider the offline ones. But then stop while thing. And minutes not equals 30. How many minutes do I spend on the real one? Most in 30 minutes. Great. Ooh, we don't filter out the blank ones. Which means this loop never runs. And it goes on for too long. Awesome, awesome, awesome. What is pressure in minutes? Or while closed and minutes less than 30. So, and should keep this only going. Well, how'd you get there? If true and false. Excuse you. Oh, I understand what's happening. Glad I did this with a loop so I could keep track of all these. And I just got rid of my console log so we never know. Well, we know something. 2087. It's another freaking number. I should have been keeping track of these. That's what clipboard's for, I guess. It is the correct answer for someone else logged in. That's just torture. Okay, let's clipboard my values. Which ones I've tried, because we're getting up there now. Try that one, we've tried that one, we've tried that one. It's not telling me anywhere how wrong or right I am. I don't know what's wrong with my algorithm. Okay, so say we get to E, and we get to C. Right? B, C, D, E, then we get to C. Now you have F, G, H, and A. So you go to A from C, C takes you to B, B takes you to A, I guess. And what I'm using for testing, Ryan, so this is, well, I'm actually just using Quokka and the built-in Node.js assert library. So no testing framework per se, just straight up assert, which is require assert. As for the visual thing, I'm using Quokka to constantly run, and that will just explode when you throw an error, which this does. So no tests, no none of that. Boost pressure in 30 minutes. That value, that number. So this is good. Well, this isn't good, but... Huh. So my Dijkstra is correct. I feel like my Dijkstra is correct. My math for choosing the next one is a little wonky based on the flow rate or whatever. But this is correct. And we don't need that. Sorry. We do get to all of them. At least we get to all of them within 30 minutes. Drop that. Drop that. Oh, I guess we'll go ahead and chain that in there. And minutes less than 30. Sure, why not? I need something to do. I complain about this number not being right. Thing is, it works with my test case, so it's hard to really evaluate what is wrong. These are the worst situations in admin of code, by the way. When the code works and you don't know why it doesn't. How many valves do I have in this? 59. A lot of zeros. I can see why. I mean, I don't even have 59. I just ignore all the zeros. What are the non-zeros? Yeah, so KR, EG, TQ, MS. So let's look at KR. Split view this. We want the beginning prefix, so val. Yeah, Quokka is a VS Code extension, Ryan. VS Code extension only, unfortunately. Basically, it runs the code in the editor, though I will definitely be adding a command for that to explain. So flow rate of 18 multiplied by 4 versus 8 times 5. Why didn't you choose this one? I'm choosing the most flow rate. I'm not choosing the most, what do you call it? Go away. Close. Close. Close all the things. My first isn't close rate. It's based... No, it is. Our next value for you is DD. For KO, it's 18 times 4. I'm just bad at math. Hold on. I just realized the tunnels have nothing to do with this, do they? Dang, nabbit. HH is the first one. I bet this works. Well, that don't work. Oh, you start HHDD. Oh, wait. Why don't you start at DD? You move to valve DD. I open DD. Why DD, though? You have the highest... No, HH has the highest flow rate. Oh, okay. I have to try the simulation starting from every possible start location. I can do that. I can do that. That is something I can do. It's not expensive. I mean, it's not easy. Technically, I should be choosing a position that is least distance from all of them. Though it's technically not all of them. It's technically the next one I want to get to, though. Heck if I know which way that is. So for cost start of flow info, I guess I'll call you next valve since I am literally looping over all of you. And then what I want the best, well, that best equals negative infinity. Congratulations, we all get indents this lovely day. And then also I'm returning, oh, wrong, curly. Returning best. And we're going to say, hey, if total flow is greater than best, set that. Lovely. I'm using a const here. Fix that. Hopefully this is all copied. Great, 1640. Oh, we are literally off by 1. How have we done this? So which next value? Okay, I guess I'll make a new variable called cost start equals next value. Yeah, sure. Sure. So we say console log start and total flow. We want the failure, so we know we want the most, right? Most possible pressure, correct. Come on, math. So 1640 HH, DD is 1570. 1640. 1651 supposed to be the answer. Where my 1651 go? I broke it. I broke it real good. All these. I'm modifying flow info, aren't I? For valve, yep, I recreate my graph every time, which I don't need to do. For in minutes, next valve minutes, add to pressure. Yeah, I guess for all of them, I'll reset all these cool numbers back to everything. Flow info for each valve. Okay, that's a little strict there. We just want to set it back to these. Oh, great. Okay, Copilot, be cool. Be cool, Copilot. No, you darn. Drop commas. Select these. Valve. Valve dot equals new number. Congratulations, did that fix? 1721. Now we have an even higher flow rate. How did you do that, HH? Tell me how. Okay, who's the first? Hey, Lamb Sauce, how's it going? We over here fighting pipes and stuff, apparently. Trying to get this flow rate stuff going. Now I'm trying from every possible initial position, but somehow I goofed. Wait, is DD at least working? DD is 1651. Okay, so that's working. But now, why did I choose DD as the initial one? Even in you are currently standing in AA. Oh, it takes me the minute I'm starting at AA. Dagnabbit. Okay, great. So for every valve, my minutes to get there, and I need to choose the one with the least. Where's my algorithm, right? I have to do all this basically, and my current position is AA. So I guess I'll do this. So we'll do a lovely 4 each. Ta-da! Hello. Next valve, valve A. So I'm starting at AA. I want to get to all these lovely places. So look at this. Should be at least be able to look at this. I said return flow info. Let's see if these are at least accurate. So from AA to A, true cost is nan. I did some weird division 0 funniness. True cost was should be able to say or 0 because I imagine the minutes was 0, flow rate 0. Yeah, that was the issue. Hey, flow rate, so A, yeah, your cost is 0, also a benefit of 0. B's 13. So what's my next valve I choose from this to go to? Please don't be A, I'm gonna have to fix that. Dagnabbit. Okay, or infinity. So I don't want to care about those. You choose A. How dare you? Because I haven't actually done it. Yeah, the next valve is all of them. Whoops. What do I do with the zeros? I literally filter them out, don't I? Where'd my filter go? Thought I had a filter. Guess not. Oh, I appreciate that, Lamb Sauce. Yeah, I know. It's a tough one. The advent of codes, they scale up, and this one is no different. Basically, there's a graph, so they have places you go to on this graph. It's a pathfinding algorithm. And some of these places link to other places, and some of them link across. Each one gives you a incremental score, a pressure release, and you need to choose the right one to start at, and then the right path. So you'll go this one, maybe then this one, then back to this one, then to this one, to collect the most coins, basically. At least that's a gamified version. It's really pressure and pipes. But we are trying to figure out the math here. So DD, this is for the start positions, because I need to try every start position, which I have failed to do. So now, why is this open, close, filter, valve, not equal 0. Oh yeah, it's unfortunately the days 1 through 10 are definitely achievable down to 5 Caillou. Now we're dealing with 4s and stuff. DD, okay, great, that ripped everything off. Okay, first I have to fix DD, then the rest will work. X val not equal or dot not equal DD, continue. Let's fix this. So we have, I guess we'll look at the next of each. I know what these should be. DD, okay, what open valve did we go through? DD, DBJH, E, C, and then I guess you eventually made it to A. Who told you to go to A? How dare you? We're not going there anymore. Well, A does work, but it requires the logic to work. Why did you do not make good number, though? Why did you break the number? Number broke. Why? Wow. All I did was put you in a big loop. And you are the first one to touch it. Oh, and I didn't even get to hit all of this. Okay, I did get to hit all this on you. Did this break it? Will DD now be good numbers? Ah, yep, so we narrowed it down, folks. This is our issue. Or 0, I guess, is it. So cos TC equals if is nan TC return, I guess. Doesn't seem right. Nope, went the wrong one. What is it doing wrong, right? So minutes, I'm at AA, then I try all possibilities. Turn that back on. DBJHECA. HECA. Turn this off. Come on, you. DBJHECAI. I have extra minutes. How did I make it all the way to I? There's no globals. This is all, I'm replacing true class, I'm replacing minutes. But other things, distance, I don't even think I use distance anymore. I don't, say goodbye. What do I do here? I say true costs, I say minutes. It's the same as the rest of them. My starting is always AA, right? There's even value in the room. Ooh, I set minutes to 1. That's the problem. Right? 1651. Okay, math. Jeez Louise. Can I let it go on all of them now? Let's find out. What was the best? Oh, we have a number. 1581. Another number. Dang, nabbit. So let's look through the easy ones. 1612, 1651. So yeah, it seems to did. And then for all these other ones, we have numbers, we're trying, we're doing things, and we got a big number out of it. Don't know what I did wrong. Thing is, I thought, yes, if we get rid of all the zeros, right, because we can literally get rid of those values for at least this moment. These are the ones we have. Drop you 2. So obviously we choose, wait a minute, we start at AA. How the heck do we make it to anything? There's even a value in the room, and you and the elephants are staring at the label of AA. Is this supposed to represent the first one? Why am I staring at AA? All of the valves begin closed. You start at AA, but it must be damaged or jammed. There is no AA. How the heck did I make it here? Hey, morning, morning, KHPS. Hope your morning is treating you well. We're over here fighting with getting this working. Flow dynamics. Or flow math, basically. Valve. Okay, fine. You start wherever that is. 1704. It's a different number! I need to put this in my thing. Oh, wow. I have hit the limit, folks. Hey, good night, Ryan. Ooh, there you go, KHPS. Demand your morning to be good. Control the outcome of your days. Say that for the people in the back. But yeah, I appreciate you coming on by. Catch you next time. Okay, so this, I thought I got better. Apparently I didn't. I mean, obviously I did get better calculating, but wait, was that because I removed the zeros? Put the zeros back. 1704. Okay, I'm glad. Yeah. For sure, KHPS. Okay, I think we can drop this one. I feel like, did I come up with a too simple solution? I gotta be overlooking something here. There's some tomfoolery about. Yeah, so try starting at all of them. Set the true cost to math. Math, yeah, I do math. Right. And this works for D, which is kind of our guiding light, though it's not complicated enough to fix or break whatever is going on. Let's put that back. I think we need that. Oh, wow. Okay, KHPS. Hey, well. Yeah, that just means you're an awfully motivated person compared to those around you, so keep it up for sure. 1704. That ain't doing what we want. Oh. Is there a bad way to do this? Because I think I'm doing it the good way. Maybe I shouldn't have tried to do it the good way. What's the bad way, right? Think bad. Bad. I can't think of a bad way. I know this might be a problem. Maybe I don't need to seal this. Like right, what was sealing doing again for me? Fixes rounding errors between this one. Okay, let's say what's up here. So for this one, we say 1649 is not as good as 1651. Your total flow is not as much as you thought because you start, wait, because of something else, because of rounding, I guess. Huh. Maybe lamb sauce. Maybe that's what I'm supposed to do. Yeah, because right now I'm kind of using Dijkstra's to go to the shortest path. Ah, recursively. Yeah, I could see that. Yeah, no, that sounds like a good idea. And yeah, thinking about the solutions, what we need more than writing it. So if I start at everything here, yeah, I could see a recursion. It would basically be dynamically, I mean, it's effectively dynamically programmable recursion, keeping track of closed, keeping track of opened, and I try every possibility. That does mean, well, what are we? Something factorial, but I'm already fast, and fast ain't working. So that may be an idea. Let's checkpoint ourselves. Try and see if we can do that. Instead of just running them all, I'm just literally one's gonna try every other one. Could do that in the pathfinding to go for the first one, but obviously that's not helpful. It would be, but it doesn't really matter. So instead of trying this, I literally try every other one. So close, open, pressure, total, all these values go into the thing. So basically for every one, I need to start and try every other. Yeah, recursiving this is going to be fun. Also drop this. Next value is, or next, I mean, it doesn't even need to be in random, it just needs to be the next. Technically, the recursion is passing, I guess I don't need opened, so say goodbye there. That's just for debugging. So I need all these values and closed. Great, okay, so for const next valve of closed, okay, don't do that. So we implement our cute little function. Function do the thing. And this one takes close, pressure, total flow, and minutes. We don't need a start. Well, I guess we already have a start, or a next val. Let's move the numbers back. There we go, do the thing. Right, put it there. There we go. All of these, we are doing all the thing. I guess, I don't know, that'll be done inside here somewhere. Okay, so closed is already here, so I guess we'll start you off. Where are you? Do the thing. Oh, I put my zeros in there for me. Come on, Copilot. Yep, first one and next value is where I'm starting from. Great. Okay, so we'll have you keep track of a cool variable called let total flow. Hold on, that's math. Okay, so if do the, let's drop these out. If do the thing for all of these is greater than total flow, total, or do we turn it? What do we do with this? What do we do with you? Return total flow, I guess, or return your number, right? So const n equals, I guess technically here we need a best, don't we? No, that's not how, it doesn't feel right. Okay, why is this on fire? Oh great, because TypeScript angry. Great, we'll text this type. Great, you're a thing. Be happy. Congratulations, you just got yourself an interface. And so closed is an array view, fellas, and you are a val. N is possibly undefined, too few parentheses, or possibly undefined. Oh great, you need to return total flow. That doesn't feel right. 0. Yeah, that's 0 for you. TF equals, or total flow equals, great, still 0. Recursion's not working out for my brain. Also, that variable's not supposed to be out there. Const total flow. Total flow, it's a lovely whopping 0. Okay, so we do this, and then, yeah, we increment total flow. Yeah, I'm doing my slices, doing all of this. Okay, let's see what do the thing is actually getting. Should be getting a lot. We get all the things. Then we stop. Okay. So what is your total flowage? Ooh, we need to add total flow. Oh no, total flow is already here. It's already been added to minutes. Next value dot minutes. That is calculated from somewhere. And we removed all those calculations. Dang-nabbit. So that is calculated, I believe, the same everywhere, though. Will be safe for you. No, so when you start off, it's done like this. Well, I forgot some things. And then for initial, come on, come on. Then inside we do it the cool way. Right, we have the graph no change. And this should be fine to do so since, yeah, for next value of close, congratulations. You do that. Bad math, bad math. Why you know, like, gotta be in here somewhere. Okay, total flow. Great, lots of numbers. We love numbers. What's my number I'm getting out? Zeros. Greatest number of all. Oh, so what's happening is I am doing a return, right? So what I need to do is be, great, total flow equals, best. We need a new best. Let best equals total flow. Update that accordingly. So best equals max total flow of them. Return the best around. Quokka's doing a sleep. Quokka be sleep. It's either you're successful or you're failure. And about to wait. So you could be in recursive loop. Alright, closed is not having its thing cleared. No, I am. I'm removing it clicked and closed. Okay, we just hit an infinite loop somewhere. For next valve of closed, slice it, do it, recalculate the thingy. Har. Okay, it's gotta be. I mean, it's infinite loop. I know that much. How do I detect this one? So it started when I did this. I said, keep trying. Well, if it's better than mine, then I kind of gotta stop. No, best is these two, right? So this isn't wrong. Stop the recursion, I guess. We're back. Okay, so you want to try next valve. You want to try the valve name. Log, darn you. I said log. Okay, you can log. We know it's wrong. Log. It's a recursion, not the end of the world. Is it closed empty? No, wait. Quokka's not running any of these freaking lines. Oh, come back. Eh. Eh. Come on. Come on, Quokka. I trusted you. You were the chosen one. Okay, it's running and then it's dead. This isn't good. I kinda was using you, Quokka. Oh, you're showing now. But now you're not showing. Yeah, we know it's wrong. Okay, that's an infinite loop if I've ever seen one. Yeah, so we choose A, we go B, C, D, E, F, G, H, I, J. Then from all of those, we choose B, C, D, E, F, G, H, I, B, C, D, E, F, G, H, B, C, D, E, F, G. Yeah, so it's getting less every time. This is literally the most inefficient way I could have done this. I need a dynamic programming solution. How many things would I need to dynamically program? So I need to choose which ones I choose in a way. Something like that. Eh. Uh, It's a toughie. So the problem with my initial solutions wasn't that they weren't running. It's just that they didn't return the right number. Maybe I go back to them. So I need a cache somewhere. At the very least, I have to start caching somewhere up the chain. And this is part one. Dude, I hope it's probably harder for part two. This recursion does not feel like the vibe. No, it does solve it. It's just, I mean, it doesn't solve it at all. I don't see why this is wrong. It's not trying every possibility. Okay, I get that. Trying every possibility took me into a whirlwind of a nightmare. Excuse me. Okay, so if I were to dynamically program this, these are my variables. Technically, these aren't. This is just my result. I guess my result is technically total flow. The maximum flow we've gotten is dynamic programming. Yep, yep. Yep, 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 yep. Of course, maybe. I mean, we're fighting against the clock, but I am not seeing where I missed it. Yeah, might as well take a peek, I suppose. Where's the big one? Eh. Oh, where's the other one? Uh, oh, geez. Only 200 people have solved. Which one of these? Gold double. Yeah. Eh. Oof, tough one. I know the zeros turn into something. That's probably the part two. It's a dynamic programming problem, though. That recursion was infinite, so yeah, can't just brute recurse it, I don't think. Oh. Okay, maybe I overcomplicated it. And it is as simple as a breath for a search thing. Hmm. It is a tough one, though. I never was good at dynamic programming problems. Generally I've been able to solve these, but I might not. Well, I think a break might be in order. Because I suck at dynamic programming problems. Okay, at least for part one, it should be brute forceable. I'm not sure why it's not brute forceable. Hmm. Yeah, okay, rewriting part one to at least. Okay, so the goal is to rewrite use BFS, rewrite to keep track of total flow at point, set of minutes flow etc. Then we'll try and figure this out because we need to. It's part two. I can definitely see as if this doesn't need it, the next one's gonna need it. Dynamic programming to keep track of all the states. Huh. Yeah. Time for a break, unfortunately. I will see you at the end of this. Catch you on the other side, folks. It's a tough one. Welcome on back. Didn't really think any good thoughts about this solution to be on, or this plan for a solution to be honest. My brain is just not up for it, it seems. Because this is working. Now it's using pathfinding to try and choose the right ones, which is wrong. Because we need to try all of them. Which means we don't need to use BFS. We just need to try all of them. Which means the recursion is correct. It's just gonna take a long time. It won't work for part 2 in the slightest. Wait, which one's the recursion? Where's the recursion? Here's the recursion. Try this one again. Back to the recursive approach. If we're trying on the easy one, which I mean, to be honest, what is it? Node 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 factorial, I guess, right? Oh, it's a big number. Okay, I understand why it's not liking that anymore. Ah. Wow, I am just not thinking of anything this one. You know what? Let's give ChatGPT a try. Getting a little desperate because my brain. I did what I thought would work. This is like the edge of my. For anyone who knows me, you know DP is not my expertise. I can recite you dynamic programming problem after dynamic programming problem, but doing them myself. Great, gotta log back in. Is not my cup of tea. Oh, forgot to switch back to the coding screen. Yeah, there we go. I'm trying to remember which account I had this on. Oh, this is day 15 or day 16, so I don't even know if GPT can help me. Great, sounds good. Okay, we're back. Okay. Okay. Let's see if we can do some cheaty. We could solve this problem in JavaScript. Great. Okay, it's doing hard coding. Love that. Probably gonna have to tell it to continue at this rate. Oh, does it give up? Okay, it didn't give up. Is this how ChatGPT works? Is it generating this live? I thought this was, animation of typing, but geez. This is how long it's gonna take. At least this is accurate. This cute little object here, which I can more than easily generate this from my actual input. Great. Minutes to open valve, between valve. Great. Map of valves, keys, data's value. Okay. Sure. Open valves, initialize to AA. Total to 0. That's weird. It went straight to JavaScript. Elapse to 0. Keep going until 30. This already doesn't seem the right way. I'm gonna hit my 500 token limit. Keep all these comments out. If not, a moment. Send a minute opening. Great. Total flow. Okay, we love that. Spend a minute to move to the next valve. But what's the next valve? Choose the next valve. Okay. Of connected valves. That's not really accurate. Maybe that is accurate. If flow rate greater than max. Okay, this isn't really accurate. But I'll give you a shot. You're also missing a lot of functiony parts, but we believe in you. Where did the symbols go? Where did your symbols go? Oh, I guess I took some off. Come on, give it a shot. We believe in you. Give it a shot. Oh, VS Code's even abandoned me. Come on, don't abandon me, VS Code. Okay, TypeScript's accurate now. Valves, data. You have all this data right here. Okay, we'll check you some annies. Cute, cute, cute. Please run. Yeah, put a whole bunch of junk, because we still got some consoles lying around. Say goodbye to that one. Try it again. I said try it again. Undefined. We love undefined. It's our favorite number. Oh, we never called this, I guess. Cool, cool. Sure. 23. Really? 23. So I shouldn't have expected that much. Zero, 20, 23. Well, that was a real good try. Ah, damn, thing is, I'm doing this one correctly. Yep, DP is not my brain. Okay, so I think it's gotta be recursion, but I have to rewrite this to be recursively compatible with a cache. Yeah, lamb sauce, my brain is imploding, alright. You have the implosion. Of this code, yeah, this code doesn't really do anything. So I need to keep track of current. It does need to be this recursion. Don't need to cache all this stuff. All of this is moving, so I need to reduce this data down to something that I can use. Huh. I guess the base case is if I'm out of minutes, right? So at some point I'll fix this. But if minutes greater than or equal to 30, I guess I'm returning total flow. And then we have our best, which is great. I need a huh. Or I should just redo it. Yeah, okay, so let's redo it from the base up. We're starting at... Wait a minute, we're always starting at AA, right? Well, not for the other one, right? For the other ones, I don't start at AA. I start from anything in the universe. Because there is no... I never understood that. Maybe that's what I got it wrong. Maybe that's why my root fails. I don't have an A... Wait, I do have an AA. It's right here. Oh my... Jeez. Okay, where's the one that works? Not this one. This one worked. Yeah, this one worked. Don't know why my brain was like, we don't start from AA. Apparently, it exists, like, right there. 1581. Did I try? I did try 1581. Nope. But AA isn't necessarily... Nope. AA. AA. 4, 5, 6. Yeah, nope. No, it is. Never mind. Am I filtering out all the zeros? I need to not do that to them. Nope, wrong code base. Here's my filter. Nope, but they're all here, so everyone's got a fair chance. Hmm. Yeah, because I'm doing count up. Let's rewrite it to be going down. So I do start at AA. That part is not confusing. It's always AA. I'm not doing the try everything again. I do need to keep track of best. But best is in our function. I'll be returning it. That's how the recursions recur. So say goodbye there. Then return. Recur. Nope, I don't have it. Be cool. Const cache equals new map. This is gonna be fun. Function recur. Oh, great. What's this? Valve name AA. Sure, AA. Yeah, Universal. I mean, I'm right on the edge with you on this one. It's pushing me. Minutes. Let's do minutes left. Let's not initialize default values. How dare you? But yeah, I did BFS, and it did get work. Like my BFS actually does work for the example. Works great for the example. Spits out some random number that's not the solution for the actual code. So my problem is that I don't know how to make it work right, universally. And my idea is that it's probably some dynamic programming things, like you have to try every actual possibility, but cache it and be smart and all that. But my brain has never been good at dynamic programming problems, so struggling to implement it. If minutes left. Yeah, we might go negative because of math. Let best equals, yeah, return best. Well, thank you for tunnel name in, maybe I could do that. I don't know about that, Copilot. Well, I also need to keep track of the one that are opened, right? I guess your set will be cool. Set of strings, right? So we yep, none of them are open. Congratulations. If well, we're not doing cache, stop doing cache. Well, I mean, we'll be doing cache, but my brain's not there yet. Opened has val, so if it's opened, no, then we don't do that. If we haven't opened it, then we want to open it and do the math. Thank you, math. Good try. Okay, so this is backtracking. I need to do the math now. At some point, I gotta return my actual stuff. So instead of open being a set of the strings, what if open is a set of... No, that wouldn't work. You're gonna keep track of the values, but those are always gonna fluctuate. So what my best will need to be is something like this. Yeah, so this is kind of what I want. Let's go ahead and add to opened. Well, let's not use an array or a set. That's gonna make it harder for my life. Copilot actually was pretty close on this. I don't think I'm doing backtracking though. Let's go recursive calls. Total name, minutes lamed. Minutes lamed. They are lame minutes. Open val name. There we go. Hmm. Yeah, I mean, I don't know. I mean, I assume. Yeah, maybe that's also my issue. My Dijkstra's not fully implemented. Update the total output during the brute or the by the searchy thing. Yeah, so the way mine did is I tried every starting position trying to simulate like how much it got through. And mine was every time I was at a new position, I would BFS to the next one. So starting off my current location, or I don't know which one this is. Is the search the one? It's the first one that makes it, so I think this is Dijkstra's. Yeah, shortest path. And then once I make it, I then calculate how it really costs to get there, which is the flow rate divided by the minutes. Then choose the next one based on the least cost, or if the cost is equal, the shortest to get to, which works on the first one, but not on the real one apparently. So best is max best. That's a pretty good start there. Opened is all of these. That's a pretty good start there. I'm gonna update my new flow, alright? I just need to try all the other ones, right? So I have to go through the graph. For tunnel name. This is going through the graph, or the neighbors rather. Yeah. I mean, I think the accumulation over time, again, I barely got that working. Yeah, I kind of manually simulated it, so I didn't really do the math behind it. I was just like, great. For every minute that increases, add to the total flow by how much current the pressure is. And every time I open it, increase the pressure by that much. So this is how I did my accumulating total flow. But it's not scaling, obviously. And it requires a lot of variables to keep around to calculate every time, which is, I'm trying to do it this way now. So I'm trying all my neighbors. The best is, okay, it's literally going to be 0. I need to get the current value. So the value is the math of how many minutes are left multiplied by current flow of opened. So const value equals minutes left multiplied by flow rate. So it's not undefined, don't worry about it. Then I add the value, because math. What are we returning? Ooh, this is... Yeah, I saw this one. I'm off by 1, so I'm either this way, this way, this way, this way. No, okay, obvious. That's not what I wanted. So it's trying a thing. I'll give it that. I'm also not caching anything. And it's the left. Yeah, so this is going from A and literally trying, hey everyone, give it a shot. Opened. I might as well look at opened, huh? Let's see. Opened. What do we got here? And best, I suppose. Because best is the more important aspect here. Yes, we got all the zeros. Where's the one I care about? Oh, wait, how the heck did you open one multiple times, yeah, dummy? I'm passing this. I'm not actually... Yeah, I'm carrying a copy. What the... What? Oh, for tunnel name of graph. Ah, I have to make sure I'm not going to ones I've already visited to. Well, hold on. This is a visited thing. This counts my minutes, right? Or whatever. If tunnel if not opened includes tunnel name, only do then. Oh, bad math. So we have. Wait a minute, opening the tunnel takes time. Opening the thing takes time, right? So, minutes left -2? Nope. Don't +1. Nope. Okay, at least we're starting from A. We got that part. That's not... Okay, so I mean, I do have best here, I guess. I like to know your path, though. It's important to me. Okay, let's see what value we're pushing. Yikes. Great, this is all recursive. It's not really helpful to me, is it? Flow rates are pushing. I mean, we tried 21st. I'm glad we made it to that one first, but... Recursive is not helping me see it. Zoom -1. Is the value... Wait, I saw zeros in there. Ah, okay, if the value is 0, we don't want to really do this. only we want to try this if there's a value. Where it's -2, right? Because we opened it. Otherwise, else -1, because we traversed to it and we didn't open it. Well, I still want a copy of opened. No, go back. Because we don't open everyone we come across. Bad math. Okay, great. Still these giant arrays, but let's see if we go from... Yeah, so wait. Opened is not DD, right? So the first opened we want is technically DD. Why do they all start with A? Oh, wait, I didn't open A. No. Do I? No, I don't do that. No. What if I just hardcode this to DD real quick? No, I didn't do it. So from D, I go to D. We do it doubly. If open doesn't include valve name, open's a lovely. I mean, obviously it doesn't. So we go from A to D. Okay, we at least do that. Then we go to D again. And we're opening our parent. Maybe, yeah, we already opened ourself. We're opening our parent here. Right? Wrong? No, wrong. Right, so it's old open plus new open. We drop the minutes down. Otherwise, we just values truthy, not 0. Math it up the other way. No. Where have I gone wrong? Ooh, I'm pushing. Ah, painful. Painful. Most painful. Pushed and I mutated my own array. Value, this is opened or this is opened with not me? Well, now it's closer, but it's not right. Why you no log? Quokka, not now, Quokka. Come on, I need ya. Wow. It's a lot of logging. Okay, my brain did not read any of that. Gonna be honest with you. Okay, we want to go to D first. Wow, you don't even want to log. Cool. Love that. Well, you were working before. Well, wait. Oh, this is doing UN, huh? Okay, that's not cool. 1630, not 1651. That sounds like an off by 1. 1709. Are we ending too early? +1. Nope. So I've gotten 1630 in the past. Why did I get it in the past? Melt me brain. So 2 to open, right? We don't 2 to open? Nope, we need 2 to open. Maximum call sack. Wait, one says maximum call sack, one says green. What the heck? Oh, this infinite looped. Understandable. Nope, -1. Off by 1 somewhere in here. Where is it? Okay, starting at A, minutes left of 30, opened of whatever this is. If I haven't opened it, let's say, let's make a new opened equals congratulations. Then we'll spread new opened over all these cool things. Although, let's do that. Nope, doesn't like that one. 51. Okay, instead of just returning best, I also need to return. This is my math. Because I'm doing math now to figure all this out. Don't do me in. Did it. Am I at least getting... Nope, not getting that. Painful. Pain. 31 minutes. Did I math it wrong? Nope. 29. 31's a close, or 30 rather, is the closest. I am 21, 30, 40, 50, 21 off. 20, yeah, I'm not seeing how I'm off that little. Okay, let's hit 29, 15, 51. Literally 100 off, that doesn't help. 31, 50, 60, 70 off. 21 off. Okay, I think this one's... Yeah, it's literally not changing anything. Loving it. Okay, we haven't opened this one, then we're going to open the next one. If value, maybe we don't need this logic. We just always give it our best shot. No, do not always give it our best. Don't open everyone you see in your face, apparently. So, it's always math max. Ooh, I lost my value increment here, didn't I? Or do I not open them? Okay, doesn't seem to have a difference. Yeah, because this is if I'm opened. I am going to the new tunnel, always. My graph is correct. I didn't break graph. Yeah, A goes to DIB. B goes to CA. C goes to DB. D goes to CAE. EFD. FDG. Yeah, this seems to be correct. And JI and IAJ. Okay, graph is not broken. Glad to hear it. I might have to actually physically just debug through it and see where it branches off wrong. So let's stop clock and dive into the deep. Okay, so we're at A. We want to go to D. If we're not going to D, we don't care. We open A. Why are we opening A? This isn't what we're supposed to be doing. We're not supposed to be opening A, but we are. A, appreciate the follow there. Friend, hope your evening, day, or probably day or night is treating you well. I am struggling with advent of code. So we calculate the value, but we don't actually do anything with it because it's A of all things. It's a 0, right? Then we go to all of our neighbors. So we're spending a minute to go from A to D. Yes, that's tunnel name D. So get in there. Okay, you're only traversing. Great, we're on tunnel name D. Now we need to go to the next tunnel. Technically, well, we need to open D. That's what we need to do. Did you open it? Yeah, we have 560, which 20 times 28. Oh, look at that. Math works. Glad to hear it. Great. So now you're going to go in here and you will go to the next one, which is C. So yeah, I do move to C. I don't open it, though. C does have a value, so I would like to open it. I need to do both of these. There it is. I always open it if, I don't know. Turn clock back on. Come on, clock, get in there. Oh, where's my console log? I don't have any. What are you angry about, Quokka? Are you running real data? Let's stop that. Tell me what you want, Quokka. Quack, quacka. Whoa, Aaron, thanks for the raid. I appreciate that. Those who don't know, does some pretty cool Godot streaming over there. Pretty chill time, always a good vibe. Yeah, thanks for all y'all for coming by. We are doing some Advent of Code, and it's a toughy one. Y'all came by on a tough one. Hey, you got me good there, Aaron. But yeah, we are definitely doing a tough one. First of these Advent of Codes that said, do math, do big math. I could code a backflip for us. Well, I don't know about a backflip, but I will try my best. Thanks. Howdy, Yuri, Lucille. Appreciate y'all coming on by. Yag, of course. Yeah, let me break down this challenge. So we have a bunch of tunnels. So we have A, which goes to D, I, and B. Then we have B, which goes back to A. So it's 2 trains. B goes to C and A. So look at this little tunnel. There's also a tunnel here. Tunnel here. Confused yet? Don't get too confused. So you have lots of tunnels. Lots of them have water pressure rates or whatever. That's just extra math to confuse us. We got to do math of these to figure out the best, most optimal way to open these to receive the most pressure over time. Hey, Yuri, thanks for the follow. If that hasn't confused you yet, well, I would love to know the answer, because we're trying. I think my solution, or my needed solution, is a dynamic programming one. So it's a toughie. Hey, of course, Aaron, I appreciate the raid. Yeah, make sure to go get that food. Gotta fuel up for the next one. But yeah, we're just doing this over here in TypeScript with Quokka to help, though Quokka has abandoned us, so we get no editor support. Yeah, we're making slow but possible progress. But now we're a recursive solution, and we think it's recurring too much. So we're gonna debug this and figure out what is up. One thing I do, or I was doing before I lost all my time for these Advent of Codes, is I also did some cool, in my opinion, visualizations. So let me go find one. I think 6 is my favorite. No, 5 is my favorite. Off to the races as we watch Crane Game. It's a crane. Cute little ASCII crane. So yeah, just, I think y'all might have saw this already, but it basically just drags boxes from, oh lord. Oh, I'm dragging my mouse. Oh, I broke that. So it's simulating a bunch of stacks, which, so like algorithmically, it's a somewhat of a lesson. You see how you move items from one stack to another. Yeah, a germinal crane. It's a terminal crane, but yeah, I like germinal. That's funny. Yeah, so it wasn't too, like, it was my first time using the Blessed library. Hey, appreciate the follow there, time enjoyed. And I got no idea how bad. I mean, yeah, Unfortunately, well, so all of this, I will pull back the curtain for y'all, let you see the secrets. My overlay is a web app. So yeah, you're just looking at a React web application with my video being shared in the background. So, ta-da! I'll even let you know how to do the border. It's a gradient being hue rotated. So, surprise! It's no overlay. It's a web app. I think the bots. So where's the bot doing? Yeah, bot should be alive. Eh. Oh, well, I guess it's not alive. That's supposed to be for the task tracker, but it's not alive. Yeah, the terminal one. Yeah, this is my first time using Blest for the terminal one, which it was fun. It's a pretty cool terminal emulator, honestly. As you saw as I was dragging my mouse around, it even works like it shows your mouse movement, so you can do mousey stuff. Ah, it's fine, time enjoyed. No, I was just telling you how like my overlay is just a bunch of web apps. Do the thing. We love doing the thing. That's do the thing, Kronk. Pull the lever. Not that lever. Yeah, it's pretty good. It's JavaScript. It's all JavaScript. React specifically, though. Angular, any JS could be done with that particular layout. Just React is my vibe. As you can tell, JS is where I live. All I really got OBS wise is like a few scenes and this cool pixelation effect. There we go. Okay, let's figure out where we're at in the code. So you would use JS for the front end, and then the back end might be Python. I mean, they showed up somehow, Aaron. Totally. They just happened to show up when you raided. What a coinky dink. Okay, so we're stepping through the code. We are not opening A. Nope, we fail to open A. Then we go to the D tunnel. Oh yeah. This one is a toughie one time enjoy. How far are you caught up? Or did you mean catch up on the last day? Because, yeah, there are quite a few who are like, time zone sucks, but try to do it day by day in their own zone. Okay, so we opened the D, which means to go to everyone else, we need to do that. Now, the correct path is open valve. There we go. So we need to go to B, but we need to go through C. So to C we go. I said to C. There we go. Okay, so now we're on valve C. And we're going to go to valve B. Now, do we actually open the C? We don't. Aha, now we're going to valve D. Well, this is going to fail us, so we'll loop on back. Yep, failure. Be nice if we didn't do that at all, though. Yeah, my usage of this is not good. No work? Wow, I missed out. We love a good no work stream. Because I don't want to do this anymore. This ain't fun. New set. Although technically, yeah, so let's do this. If valve value. Actually, we don't want to go this. If tunnel name or if includes or if new opened no all the things. There you go, yeah. I don't think the extra function call is really destroying my universe. We just need to use a set. use a set the cool way. Now this one we're passing opened, which I believe we can do that, so loving that. Now new opened, you're the weird one. New set. That was a screenshot. I just want to remember this moment, folks. Did not accidentally hit the screenshot key, and not at all. This is where the terminal wakey. Solutions 2022, solution 16. Oh. Run the code, cronk. A little tough for that one. Okay. Gotta be a recursive loop lying around here somewhere. We just gotta find it. You still running? Okay. There's a recursive loop. Okay. Yeah, I don't want that running anymore. So we go from A. We go to D. Then D takes us to C. And then we don't want to open C. So we're gonna go on through. You're gonna open C like the bad. Now you're gonna go to D, which I guess will take you back. Yep, and then you'll try and go to D again. Okay, this optimization can be fixed. Basically, if this has been opened at all, if tunnel or if new opened has tunnel name, say goodbye. So boom, that optimization saves the universe. It's our solution. No solution. Okay. Try it again. And stop. That's not helping. Okay, yeah, so we go from A, then we go to D, then we make it to C, and then C, you're going to want to go to D, but you're not going to be able to. Then C will take us to B. First, I'll try to open and go to C. And then you'll try to live your life here. We love that. So I need to keep track of all this. DCB. We gotta wait until we go back down to D and C, I suppose. DC AI. We hit a loop. That's what happened. So we hit a loop. Why are we looping? Why are we crazy looping? This is where I use the cache, ain't it? Yeah, I never actually used the cache. How does an LRU cache work? 'Cause that's the Python, what I would write this in. Least recently used cache. It's smart. I gotta use the docs. Because it makes the recursion call basically check, hey, we've been here before. It returns the same as LRU cache. Smaller and faster. Yeah, we love LRU cache. Memoizing serves up to that many calls. So aside from that, okay, we can do this. Since we find a best, we're like, great, we found it. Cache.set. Put all of that in the thing. I guess that's basic stringification. Great, okay, so math is easier. If cache has, return value, cost CV equals cache value. We love ourselves some cash money. So if you have it, return it. CV not equal undefined. Turn it. I think we're fine. Const CK to calculate the cache key. Someone needs to do that twice. Okay, let's see if that is helpful. It's not much of an optimization, but it'll stop the infinite loop. Oh, when we have numbers, they're the wrong numbers. Oh. Well, that means we can turn Quokka back on at least. Quokka, save ya. Maybe we just off by one this, right? Right? Math. Aha. Aha. That's obviously not the solution. Maybe I don't -1. No, I think I definitely -1. Okay, so we've been there, say toodaloo. If we haven't been there, we decrease minute by 1. Use opened. We're not ever actually adding to open, so it's just transitive logic. Ooh, I'm using this. Might need to sort to make sure those keys line up. Not gonna help this. Ooh, now we're off by 1. Amazing. Well, it's not really how smart of a cache works, though. We'll have to find a better value down this path. So if we don't use cache, everything catches on fire, right? That's the fire. Yes, yes, yes. No fan of fire. What's our current valve? How many we got left? How many we've opened, or what we've opened, rather. Interesting. So if we're opening this one, or if we want to try and open it, then open it with our max best plus value of our attempt to open it, which is -2. Yeah, this is valid. Maybe we don't say new opened, we just say, so this one is this logic. So if not new opened, and this, otherwise if old opened, or 1631, where we break it. Yeah, because we don't want to go somewhere we've already been. Now, if we've been to this one, if not, basically this not, but instead of valve name, we say tunnel name. Da-da-da. Parentheses everywhere. It is supposed to be 51, right? Now I'm questioning the numbers I copied. Yeah, this is technically working. I mean, it's not, but what if I just ignored it? Wow, that's on fire. This is the part where you console log. Or do we hit a map? Too many things in the map, maybe. The map is too large. Yeah, the map's too large. Okay, let's go back to what I thought this was, because this was good logic. It was good logic, then it was bad logic. There's something I'm missing dynamic programming wise. Because I don't like dynamic programming, that being the reason. I am trying, folks. It's the greatest scale up, at least it's in the last few years. Got really hard, really quick. Ooh, tough one. Why? I still don't know why I'm literally 20 off. 20 off. That's one counting of A. A got calculated off by 1. But then that's too many. So what, if open is empty, you'd do one more? I can do that. Opened size. So if you got something in there, it's -1, else it's 0. Well, that's not what I want. I wanted what we're subtracting to be ternary. Well, now it's the wrong way. -1. 16. Oh, no, wait. 1650 to 51. I thought I was 1 off, not 2 off. 30, 40, 50. I know how math works. What's the big idea? Oh, was it new opened? Oops. Well, now that's not doing anything. Because it's always going to have at least 1 in it, right? Right. Well, don't know how that got there. Interesting. Is the set ordered? No, it's not ordered. Yeah, stepping it through to the best would be the way to go. Stop all and get all the values as I do so. Into the depth again. Okay, so we want value. At least I can write that. Great, value 0. We love that. 560. That is, who are we opening? I will show you there. DD. Yep, so we're opening DD, which... Oh my goodness. I need to time travel. When I last ran that code. Oh, it's part 2. Now there's 2 of them. Now there's 2 openings. Oh my, Control C, stop rendering weird. Okay, I need to stop and go back to when I just ran this code. Oh, I hope I still have it. Oh no, this is the cache. I need to go forward then. Yeah, so what I did was I literally was like, hey, funny if I just did this and it freaking worked. Right? So we're gonna save that. We're gonna run that once more. And let's look at this part freaking 2. 4 minutes to teach the elephant how to open valves in the right order, leaving with 20 seconds to 6 minutes to actually execute the plan. Assume that you teach the element before opening any valves yourselves, giving us both 26 minutes. I move to 2, element moves to D. I move to J. Element moves to D, you open J. So is it still the same order of valves? Where's my highlighting? So we open D, J, B, C. D, J, B, B, H. Huh. How will they synchronize up though? Because the elephant will need to, like, we can't both go to the same one. How bad did I actually do on the first one at least? Let's take a look at that. Ah, I don't feel too bad, but I don't know with this part too. Did we run? Okay, we ran. What is the time on this? Well, here's the thing. It doesn't even work on the correct one, which is like, why I couldn't never actually went for it. Yeah, I'm off by 1, which apparently don't matter. Then I have to do the same thing. 2 of them. My word. Ooh, here's the thing. I barely understand why part 1 works. The fact that it doesn't work on all of them just breaks my brain even further. Ah. Does work though. How long did it take? Show terminal? Wow, it takes 15 seconds. Okay. So this works. Darn, I can't even use Quokka to actually figure any of this out though, because it takes 15 seconds. And you're not going to show me any of that. So all my tests are going to be at least 15 seconds apart. Did this actually help? 15 seconds, great. So we're going to 40. Did that run? Ooh, it actually did ran 1584. Okay, I didn't need that check. Nice to know. So this is technically enough. How do I do the double cache? Is it just doubling it? If I double, so I keep track of the ones open, right? We got that part working. I keep track, my valve name just doubles, right? And I do this twice. It's gonna double everything though. Valve name, great. It's all, ah. So human valve here. Elephant valve. String. Why are we teaching an elephant anyway? Where is this store got to us? Okay, so we only have 26 minutes, so I guess. Congrats, you're down to 26. Yeah, we're not even using part 2. Oh, wait, we both start on A? I and D. Did we all move from A to that? Great, so we all start on A. Glad to hear. Okay, I was about to be like, is that why? No, that works. Okay, so we need to figure out something about this.